Okay. So, while concluding, yesterday I mentioned one very important point that means field selection is highly important. And when you consider a field, when you finalize in this area you want to make the career, then actually you should understand what actually the work is going on in the industry, what are the expectations of industry, and what skills are expected, because you expect long term sustainability and growth as well. Now, the basically speaking, as we discussed yesterday, what happens now when we talk about embedded systems, majorly two parts are there. One is a software which we called firmware. This point also we discussed yesterday, but I will a bit elaborate on this, and then we will start with some technical discussion, some topic also. And other part is a hardware. As I mentioned, generally what happens when hardware is designed, redefinitions, redesigns happens less frequently. So generally this profile has got more requirements in the market, and generally practically seen more financial growth as well. There are some people, especially in mid-scale companies, some people work on both. Means these two are different skills to have. Firmware design will majorly be like a programming side, and the hardware designing will be purely hardware side, wherein you will be involved in circuit designings and making the circuit, making the hardware itself. That's the point. And here on the firmware side, there are lots of opportunities in various areas. The areas of embedded systems we discussed yesterday: automotive sector, military areas, medical industry, IoT, and lots of other home appliances. Lots of areas are there where embedded systems find application. Now we are basically, the courses which we have designed are targeting this profile, embedded firmware engineer. But it does not mean ki you just need to understand or learn programming language and that's all. No. So here I will give one example. Suppose in case if you come from electronics background, you will understand this. If not, still you will get some idea from this. Means what is the final goal? Say, suppose if I have one microcontroller, any one microcontroller, and suppose I have connected one transistor to one of the port pin, and the emitter of the transistor is connected to ground, and in the collector I have got one relay connected. So say 12 volt DC relay is connected, its coil will be activated on 12 volt application. This is my relay, and then it's connected in the collector of the transistor. Through relay I have connected a light bulb, so it's a complete circuit, and this light bulb has got a 230 volt AC supply. So what I want is, suppose if I connect some switch here to the microcontroller, whenever this switch is pressed, this light bulb has to turn on or off. When I press a switch, the light has to turn on, and when I release the switch, then the bulb has to go off. Now on controller side, two things are expected. The first is, you first of all detect the switch is pressed. So how would you detect? For that you have written some code. That code you have loaded in the microcontroller in the program memory. So for switch detection you have some code, and then whenever switch is pressed, that you detect through the code, then you activate this bulb. Now how the bulb will be activated? The bulb will be activated when relay will be activated. Relay is basically the electrically activated magnetic switch. Magnetic field is generated, then pole is attracted, and then normally closed circuit is there. It completes the path, and then the load gets activated because the supply gets connected to the load. Now, how the relay will be activated? Relay will be activated when the expected voltage is applied across the relay, and when obviously current flows through it. When current flows, then only potential drops. So current has to flow. How the relay will get activated, how the current will flow. When the transistor is activated, this BJT, bipolar junction transistor, has to get activated, then the relay will activate. And how the BJT will get activated? So I need to send some expected, this is the base resistor. So I need to send some expected signal to the base of the transistor, and it has to enter in the saturation mode, acting as a closed switch. Then the path completes, relay gets activated, and so the bulb get activated. Now I need the knowledge or understanding of few things apart from programming. Programming is a one aspect, means what code I have written for detecting a switch. That's a one part, coding part completely. But then there will be some questions like, when switch is connected, how will I come to know switch is pressed? What should I check on the pin? Another question can be like, okay, I got to know the switch is pressed, but then how I activate this transistor? Because when I activate transistor, then relay gets activated. When relay gets activated, then the bulb gets activated. But how the transistor gets activated? Should I send 1 to the base of transistor, logic 1 or logic 0? What should I say? What should I send? Now again, that is dependent upon the type of the transistor. So the next question, when I ask how the transistor will get activated, the question will be key, that is dependent on what? That is dependent on whether that is NPN transistor or PNP transistor. So the point is, when I write some code, some C programming code on my laptop, that is completely different. And when I write C code, embedded C code for any microcontroller, that is a different. Code itself is not different, means language itself will not change. We will talk on that point also. Okay, what is the difference between C programming and embedded C programming? That will be a separate point of discussion. But then what additional skills I need other than programming? So that's the point. The point is, you need to understand electronics hardware, how switch works, how BJT works, how MOSFET works, how relay works. Then can controller fulfill the electrical specifications? Means, can I not directly connect relay to microcontroller? Do I need this BJT in between? Can I directly connect relay to microcontroller? So this when pull-up resistor is needed, when pull-up resistor is not needed. So lots of questions are there. And now I need to understand how this circuit works, means basic understanding. Maybe not from designing point of view, like I have this RB base resistor. So programmer will not responsible for deciding the value of this resistor, or even deciding ki, this BJT will be what, BC547 or some other BJT. What are the electrical specifications of this relay? Means which voltage should I apply to this relay so that it gets activated? So this hardware details, firmware developer will not be responsible for, but firmware developer should know what should I send to this circuit so that it gets activated. And I need some awareness about electronics also. So in laptop, it doesn't happen. In my laptop or desktop computer, when general purpose C programming I am writing, then I don't have to know the architecture of Intel machine. In your laptop, you must have some processor, है ना? Intel processor or AMD processor. Do you know the internals of Intel processor? Do you know special function register? Do you know architecture of Intel or architecture of AMD, whichever is the processor? Do you know how the processor is connected to hard disk, how the processor is connected to RAM, how the RTC is working on your motherboard, real-time clock? Are there any analog signals involved on your motherboard? How analog signals are getting handled? So lots of questions are there. How power supply is getting managed? So you are responsible for nothing. Means even if you don't know anything about electronics or hardware or motherboard or processor, still you can write a C program for your general purpose computer. But in case of microcontrollers, that is not possible. So embedded C programming, specifically speaking, that is called as a bare metal programming. There you need to understand the architecture of microcontroller. First thing means how much memory do I have, how much data memory, how much program memory, what are the special function register, what are the ports, which ports have internal pull up, which ports do not have internal pull up, how ports are driven high or low. Then off chip peripheral devices, how push button works, how relay works, how transistor works, and some other many more devices, like how LCD works in 8-bit mode, how LCD works in 4-bit mode, how 7-segment display works, what is the difference between common cathode display and common anode display, what is the temperature, how temperature sensor works. Means temperature sensor, in case if you know already, temperature sensor gives me analog voltage, then my controller directly cannot process analog voltage, then how that will be, who will convert that into digital? So lots of questions are there. Then other than this, communication protocol details like I2C communication protocol, how many lines are needed, how many pins are needed, SPI communication protocol, how many pins are needed, and then again details of those. So the point is, embedded firmware developer also does not mean ki you know some basic level of programming, and hardware you do not know at all. No, basically you are supposed to read the circuit diagram. Even if you cannot design the circuit diagram, you are supposed to read it, understand it, and for that circuit you are writing the code in the microcontroller. That's the job. So you need understanding of electronics. So whatever courses we have designed, in that we talk about the necessary hardware also. In the means about the surrounding circuitries, and about analog to digital converters, about real-time clocks, about external memory interfacing. So lots of other things other than microcontrollers, also lots of things will be discussed. Operational amplifiers, signal conditioning, power supply designing. So lots of other things we will be talking about. And then one more misconception, lots of time what happens generally when people complete their formal education from any university, generally they think ki C programming already I have done in my engineering. 8051 PIC controller already I have done in my engineering. So now I want to learn something advanced. So that's the biggest misconception majority of the people have. Because what happens, means I know C programming, means this is a biggest misconception in the market, especially at the beginning level. So people think they know C programming when they know grammar of C programming. So some people know if this I write condition, and then in if suppose if I write this code, then when this code is executed, when not executed, how if works, how if else works, how switch works, how integer array, character array. So they know grammar of language and they think they know programming. So first of all, I would like to clear this thing, complete clarity, that programming is a different thing and programming language is a different thing. For example, suppose if I say ki I know the grammar of English, I understand past tense, present tense, future tense, and other grammar also, now pronoun, verbs, everything. Grammar I completely know. Means if you give me a question paper on English grammar, I can score well. Does it mean I am an excellent orator? I have excellent communication skills. Can I say so? Can I claim so? No, that is not the thing. So knowing grammar of a language is one thing, and becoming a good communicator or being a good orator is a completely different thing. है ना? So language is basically what? Any language, whether it is Marathi, Hindi, English, any other language, even programming language, C programming, C++. So when I say I know C programming, then basically majority of the people mean they know grammar of C programming. So if you know grammar of some language, that does not have much value. So you will, out of 100, if you want to rate yourself, if you know the complete grammar of any language, you can hardly rate 10 out of 100. So when can I say I know programming or I know programming language? You can say ki I am a good programmer or I know programming language well when you can think like a programmer. Means if you are given a problem statement, so the first is, so can you understand, you read, do you first of all understand how to read the problem statement? Because sometimes problem statements are not as simple like multiply two numbers or divide two numbers or calculate factorial. No, sometimes problem statements are 10 lines, 20 lines big. So sometimes it is tricky to even understand the question. That's the first question. Then second question will be, okay, you got the question. Then can you design the algorithm? Can you design algorithm, working algorithm? And can you test also without actually writing the program, actual code? Can you test the algorithm? Can you give confirmation, yes, if I implement this algorithm, it will work? If it is so, then only you are allowed to go in the next step. And more top on the top of that, can you say ki whatever algorithm I have designed, that's the best possible algorithm? Because generally what happens, if you say ki I want to go from place A to place B, often there are multiple paths. So say path A, path B, and path C. Same happens in programming also. When you say I want to implement this program, then there can be multiple paths. From A to B, you can go by multiple ways. So intelligence is selecting the shortest path, because resources are important. When you make some program workable, it is also important that how much memory you are investing for your program, how much time are you investing for your program, is your program efficient? And efficiency of your program is directly proportional to power consumption. And in embedded domain, power consumption is highly important because many products are battery operated. So good quality software will consume less power, so more battery life. So that's important. And also memory consumptions are proportional to power consumption. So making something workable means, in college what happens, if two people have written, two persons, person one and person two, person one has written some code, person two also has written some code, but the solution offered given by the person one student is very compact. He is using less number of variables or less amount of memory. Other person has given some solution, it is giving output, it is working, but it is consuming more memory and more time also. Now the worst part in education system is both of them will get equal marks, because both the programs are working. So education system, exam system evaluation does not consider quality, it considers quantity. If it is working, that's fine. Or if your answer is lengthy in exam, if you have used those keywords in some specific textbooks, then many universities give you marks. So how much you score in your exam cannot be the only parameter for intelligence, and that is not what industry expects. Industry expects thinking capabilities. Can you independently implementing something? That will be the final question. And then second important question will be, can you learn something on your own without anybody's help? Learning capabilities are expected, because what happens, suppose if I ask you, I want to interface memory IC using SPI communication protocol, and suppose in your life you have never done it, and this is the first time you have to do it, and plus suppose if I also give you deadline, within 3 days you have to implement it using SPI protocol interface memory. That's how industry works. So therefore, am I ready for unknown thing? Means I cannot say key things whatever I have practiced only I can implement that thing. So industry does not work like that. Especially the creative industry like embedded systems, even IT field also. So there rapidly things change. New technologies keep coming, new sensors keep coming, new microcontrollers keep coming, new protocols keep coming. So new things keep coming. So it's a learning is not an event. You did some course and it finished. It's a process in every field, especially if it is creative. So the major point is after adding some skills, even if you get a job, After that, can you independently survive, or you will always seek for some help? Okay, without training, I cannot do anything new. If that is the case, then obviously you struggle. So the best quality of the person, the mm, someone who is doing very good in industry, someone who is a doer actually, who is a successful in industry, the two qualities will be thinking capabilities and learning capabilities. Because if you can learn something on your own, then you can acquire any skill and then you can implement it. So that's what they expect. So now you need to go through lots of process. First of all, unlearning whatever education system has done to you. You practiced memory. Majority of the people, it is not for intended for some person, but education system is like that. More values are given to memory. If you remember some derivation and if you can write an exam, you will get full marks whether or not you understand it. So nobody will ask whether you understand it. Practical experimentations, if you write tables, if you create conclusions, you write, then your assignments will be passed without asking whether you understood it or not. So there is no feedback for understanding. So there is only inputs given for memory. So you remember when your exams are there, you write in exams, you score well and you get certificates, and that's the end of your degree or whatever certification you did. But that is completely useless in the industry expects ki you yourself able to implement it, and that will involve lots of facts. Like some facts I'll tell you. For example, microcontroller, say they ask me to work on any microcontroller. The first expected skill is ki I know how to read data sheet of a microcontroller. So there are very rare places, college level, no question. Other also in market also, there are rare places wherein data sheet approach is followed, wherein they demonstrate you ki how to read data sheet. So for example, see, this is the data sheet of peak microcontroller in front of you. So data sheet is as good as a book. It is as good as a book. So there are lots of topics: analog to digital converter, I2C, SPI. So currently I'm in the I2C topic. Then there is timers and lots of stuff is there. So you see, this data set 18F4520 has got around 390 pages. So there will be a question ki I want to program a timer, or I want to program SPI or I2C or some other thing. Then which part of data set actually do I need as a programmer? Should I read all this, whatever description they have given? So if I keep reading this, if I keep go on reading this, it will take lots of time for learning microcontroller. So that much time generally is not available. So how to read the data sheet, how to read, uh, get the expected information in a minimum amount of time, how to read waveforms, how to read waveforms, how to read tables. So tables and waveforms have lots of values, lots of value. So I should be able to understand, get the needed information in minimum amount of time. See, one more, this is the data sheet of real-time clock, RTC, real-time clock, which maintains calendar. So all these calendar related registers are there: minute, hour, month and year, and lots of. So there are tables like this, and then there are some waveforms. Means generally it is expected that you don't read this texture, instead you read the waveforms what they have given and block diagrams, and through that you get the expected information and start programming. So the first question when I start programming microcontrollers will be, do I know how to read the data sets and these technical documents? This is the data set of the RTC, I2C RTC, I2C communication protocol, RTC IC. So that's the data. Lots of technical documents are involved, and I can show you lots of such documents. So the first thing is ki, generally when I start programming, then each and every info is not available on Google. In fact, majority of the things are not available on Google. Then what is the reliable source of information? Data sheet. So do I know how to read technical documents in minimum amount of time? So industry does not accept you say ki, they ask you to work on Renesas microcontroller and you say ki Renesas I have not used, I have never used. So I will need 1 month for learning it or 15 days. That is not acceptable. So basically basic expectations are key. You have already learned how to learn. So here we target how to learn. So here we target concepts of microcontrollers rather than any specific controller. So we discuss 8051, but 8051 we discuss for creating the concepts of microcontroller. What is interrupt? What is polling approach? What are the applications of timer? What are the applications of UART? Polling approach of UART, interrupt approach of UART, external interrupts. What are their utilizations? Internal memories, RAM, program memory. So those then the external devices like LCD interfacing, keypad interfacing, switches and LEDs. So those things we talk about, priorities of interrupts, lots of stuff is there. So for that we conduct 8051, not for 8051. Then similarly, as I shown you in PIC, we follow datasheet approach. So there we learn how to read datasheet of any particular controller, and without doing much of a Google or without asking any person for help, can I myself get information and convert it into expected program? So that's the question. And answer finally should be yes. At the end, if I learn somewhere and if I am not up to the mark, if I'm not fulfilling the requirements of industry, then obviously I'm going to struggle even if I get a job. So yesterday we discussed getting a job is the worst goal, actually wrong goal. That cannot be the goal, because after getting a job, then what? That will be a question. So don't you want to survive and grow in the industry? So is it your final goal to get a job? No. So, and after getting job also, what will guarantee that you will survive and grow? Only skill, correct approach. So how you practice, what is your approach of looking at something, what is way of practicing you are following. Sometimes what happens, suppose I am at Pune and I want to go to Mumbai. This often happens. Lots of people do this. I want to go from Pune to Mumbai. So what I did, say for example, I am a hard worker. So I believe to reach at time. So early morning, I started my journey and I went. And after 5-6 hours, I realized that I reached to Kolhapur. And then I come to know that I have taken lots of efforts. I reached somewhere, but that is exactly opposite to wherever I wanted to go. I wanted to go to Mumbai, but I reached Kolhapur. So does it mean that I did not work? No, I have worked a lot. I have spent lots of hours. I started early morning. I did lots of driving. Hard working is unmatchable, but still I did not reach my goal. Why? Because direction was absolutely wrong. So practicing or doing something or hard working is one thing. The most important thing, in fact, more than speed, direction will be important. Same applies for programming and microcontrollers also. If I am spending lots of time, I dedicated my 3 months, 6 months, whatever is the span you decided to dedicate for developing skills. So the first and most important question you would ask is, what kind of processes are we going to follow for learning? And if I follow those processes, will it ensure that I will get skilled? Because at the end you will be surviving on the basis of your skills only, and not on the basis of your degree or certificate or which university, which college or what experience, which company you got job in, multinational company. Nothing matters. You got the job, you got entry, so that can be a good news for few days only. But what guarantees that you survive and grow? Only skills. What guarantees that you develop skill? Only correct practice. So logic development has to be a goal. Means now after practicing for number of years and conducting for thousands of students also, I never say that I know C programming, and probably I will never say for lifetime. That is not possible. Anybody who knows something will never say I know this, because that person understand what is the scope, how vast the scope is. Because C programming, if you say you know it, that means you are already ready for getting a job. You already can make a good career. You don't need any kind of a training. If somebody says I know C programming, then that's all. That's finished. Doing C programming means basically you are saying I am logically sound. So if you are already logically sound, if you know how to apply C programming, everything, then you are already job ready material. In fact, people industry should follow you for asking ki you come at our place and do this. If you really know C programming at industry level, because current situation is what you know. As I told you yesterday, current situation is there are lots of jobs, lots. In fact, industry is struggling for getting good people. Means whatever level of people they are expecting. You see, both side there is a complaint. Means people say ki I wanted job, but after engineering also I did not get it, or after ME, Tech, whatever is your education. After that also I did not get a job. And other side, companies are complaining. Companies are saying ki after searching a lot, also we are not getting skilled people. है ना? So does it mean कि people are not available? No. Or does it mean companies are not available? No. So means they have expectations which are not met by people, and the large credit or blame, whatever you say, goes to education system. So when you are dedicating few months for adding skills, then you should make sure that proper learning processes will be followed. And when you say you are learning C programming or you learned C programming, so finally you should be able to say, yes, I know how to think now. You give me a problem statement, I can create algorithm. After creating algorithm, I can select tools, correct tools from that language. Means I will give a couple of examples. In C programming, same code can be written by using if also and if else if also. So there are multiple ways of doing something. Which way you select, that is very important. Which way you select, that is very important. Is it efficient or not? That's the question. I can store data in integer or array also, character array also. Which array should I go for? So decision making is highly important, and that is applicable to any programming language, not only C. For example, in assembly language, I can create a loop by using CJNE instruction also, DJNZ instruction also. If you know bit of 8051 assembly programming, which one should I use? I can use for jumping. I can use S jump instruction also, A jump also, L jump also. Which jump instruction should I use? So what should I use at that point of time is highly important. So tool selection will decide quality of your software. Algorithm and tool selection. If I cannot design algorithm, I cannot become programmer. It is that straightforward. And this is never discussed anywhere generally, unfortunately. How to break down a problem statement in number of steps and how to implement every step. Debugging skills are there. How to debug a code, how to step run the code, how to monitor a variable or a memory location. That is generally not discussed. Means generally whatever is demanded by industry is rarely discussed. That's why industry also faces problems. Companies are facing problems finding good people. So if you get those tools, then you convert your algorithm into code, and then you also check whether my code is called as a dry run. Dry run the code, check if the code is working for every possible input. So you switch the mindset. So when you are writing the code, you are thinking as a developer. After writing the code, you switch mindset as a tester. So you check whether my code is working or not for all possibilities. If not, you rectify it. Finally, if you are sure your code is correct, then you try it on system. So in fact, in the beginning, as per me, computers for C programming or any programming rather, if you are learning any first programming language, in the beginning, you should not use system for programming. Code should run on paper. That makes you a programmer. So there is a specific way of practicing. If you follow wrong practices, then you will reach somewhere, but it will be, maybe it is completely opposite to your goal. Sometimes you might have heard people get job, they get some experience, 5 years, 6 years. After that, they start struggling. In the middle of their career, they face problems, and that is because of the kind of practices they followed while entering into the industry and afterwards also. So setting correct direction is highly important, first of all. And if I follow correct practices, then the consequence is what? After C programming, I take less amount of time for C++. That is a sign. That's a feedback for myself. Yes, that means I learned C properly. I can think myself. I don't copy paste programs from anywhere. Understanding code is one thing, and constructing code is another thing. I want to be able to construct a code from scratch. So if I'm understanding program, that doesn't mean I'm a programmer. If I'm practicing understanding, I will become good at understanding only. If I want to become a developer, if I want to become a best programmer, then I have to practice coding only. How to practice coding has got number of steps. If you bypass a step, gone. That's a wrong practice. You will reach at some wrong place, or later you will struggle. It happens with lots of people in your circle. Also, some people will be there who easily got the job with some reference or with something, whatever, or market scenario was very good, but later they started facing problems. Why? Because approach or attitude or the way they are practicing is not absolutely correct. Same happens for microcontrollers also. 8051, after that peak will take less time. After that ARM will take less time. And after that, when you start programming any unknown microcontroller, it will almost take no time. Means within a day or two, you can start programming any microcontroller. See, because you tell me in industry, how many different microcontrollers are there? Hundreds of controllers are there, no? Lots pick, you forget about companies. Consider pick only, one pick family, 16F family, 18F family, lots of families are there. Pick itself, microchip itself has got hundreds of controllers. ARM has got hundreds of different chips available. ARM based chips are available. ARM 7 available, LPC 2148 is ARM 7 based. Then ARM 9 is available, ARM 11 is available, Cortex A series available, M series available, R series available, STM32 available. Lots of boards are available. Then AVR, lots of controllers are available. Then after that, Renesas, lots of controllers are available. Motorola, PowerPC, and there are lots of names, ST. There are lots of companies, means literally hundreds of controllers are there. So is it possible for any person to learn all microcontrollers which are used in the industry and then enter? So this is not possible. It's like learning infinity. Can you learn infinity and then enter in the market? So that's impossible. So means people will finish, person will finish, life will finish. So it is not possible to complete study all microcontrollers and then end. Then what is the correct way? Correct way is don't learn all microcontrollers, learn the philosophies, make them concrete, so that whenever you come across some unknown microcontroller, within short time you can grasp it. For example, suppose if you learn Wagoner car, suppose you learn, you drive it for 6 months or say 1 year, you drive it and you became a master at driving. You became a master at driving. After 1 year, you purchase Audi. After 1 year, you purchased Audi. And now you want to learn driving Audi. So how much time will it take? So Wagoner was your first car and it took 1 year for you to become master at driving, to be able to drive at any road, steep road, curvy roads, any kind of a road. So you can drive. So it took 1 year for becoming a good driver, good driving skills. Will it take same amount of time to learn Audi after Wagoner? Obviously no. If answer is yes, that means you don't know how to drive Wagoner only. Are you getting the point? So Wagoner and Audi has got one common thing. What? Driving skills. So we are not working on Wagoner, or we are not even working on Audi. We are working on driving skills. Same applies here also. We are not working on 8051 peak or ARM. We are working on controller skills. So after this, you should be able to program any microcontroller within short amount of time. Same applies here also. Here we are not targeting C programming. We are targeting programming skill through C. But later that should save time. If after first, second thing is not saving time, second thing is taking equal or more amount of time, that means you followed wrong practices first time itself. This is highly important. And same goes on with communication. Every means it is not programming or embedded or controllers. It is a life. It is a life. So if you are learning, next time you are improved person, improved person. So if you are becoming a better person day by day, then you will approach with a better understanding, better understanding. So even if actually speaking, complexity increases, but learning span decreases, because now you are a better person when you approach that new skill. Same you go like C, then after that data structures, then after that C++, then after that real-time operating system. So is, if I directly go for real-time operating system, can I learn in 20 days? Can I learn 20, in 20 days? Can I learn RTOS without any programming background? No, that is very difficult unless and until you are born intelligent like Einstein, then probably it will be possible. So, but if you follow this journey, ki my programming skills I got up to the mark through C, I don't know C grammar level only. I know how to think. I know how to create algorithms. I can select best possible path. I can write programs on my own without anybody's help. I can debug programs, and lots of factors are there. Means I cannot even explain what other factors are there. Reusability, ease of modification, lots of things are there in any programming language. So I know all of these things. Then I can say, yes, I know something about C programming. And then with those skills, if you apply data, if you learn data structures, this will take hardly 8 to 10 days only after C. After data structures, it will take very less time for C++. After this, if you go for RTOS, then within 15 days, you can add it. So when you go here, actually complexity increases, but time consumption decreases. That is because you are practicing correct practices. And at some point of time, what happens? At some point of time, you become independent completely. You don't need any kind of training. You do not need any help. You are on your own. You say, just give me, I will learn and implement, learn, implement, learn, implement. So you know both things, how to learn something without any guidance, and then how to implement it without any help. If you become that kind of a person, then you reached stability. So first we need to understand that people call these companies very big or MNCs or something. Stability. Stability is a characteristics of a person, not the organization. So whether you are stable or not, that's the question. And that is dependent upon what level of skills you possess. So you just got entry level skills, or you are very firm, we are very strong at whatever skills you are possessing. That's the question. So if you get very good at it, then obviously you will become fearless. That should be your goal. And once you follow this approach, correct practices, then obviously it will not be even a question. Means people, first question people ask is, will I get a job? No, that's a wrong question. If you have a skill, you will get a job. Getting a job is not a question. In fact, at least in this field and this kind of a market conditions, that is absolutely wrong question, asking, will I get a job? No, that's not a good question. That's not a correct question. If you have skill, you will get a job. There are many people rather, who get selected in number of companies. You must have seen those kind of people also. So it's not whether jobs are there or not. No, you are in those. Are you in those category of those people for whom the companies are looking for? That's the question. And you are thinking long term for 20, 25, 30 years of span. Maybe after some time you might think of starting something on your own, and for that you are targeting a proper skill set. Getting a job is a byproduct. It will anyway happen. If you reach at certain level of skill, getting a job is unavoidable thing. You will easily get a job. What after getting a job? Can I peacefully work, or I will every day struggle? That's the question. Now, one more question. Majority of the times this question is asked, so I am already ready with the answer. The question is, okay, so if we happen to go, if you happen to, I don't know what are you targeting, whether offline or online. Currently, we are planning for one online batch. So you see this kind of codes we discuss. This is one 8051's code, Kill platform, Kill ID. A majority of you must have seen or even used in college level. If not, not a problem. I'm just showing you. So this is a code which we just discussed, I guess, yesterday itself. So we discuss code and this we try to take it closer. Means in industry, what happens, in industry, multiple C files are created in a single project. See, this is a UART and LCD. I have UART also, LCD also in same program. So I created UART.c, LCD.c, separate C files. And then I also created my own header file. So C programming has lots of depth. So how to create header file? That's the question. And why to create header file? That's again one more question. So I created my own header file. I used it in my program. So industry has got this kind of projects. Multiple C files will be there. Multiple header files will be there. In any industry application, single C file will not be there. So here it will be like what is actually happening in the industry. That's the problem. And that's the point actually. And then how do I cross verify? Okay, I understood this code, I implemented it on my own. Then how do I check if it is working or not? Then actually here we follow some simulation software. You must have heard or used it. If not, not an issue. We talk in details. We go in depth of from the scratch. Like I told you yesterday, some other branch people also approach this course. So we go without any prerequisites. We start from very scratch, means right from how to create a C project or how to install software setups and everything we provide. And we start from very scratch. So what I did here, I have some serial communication happening in this code. Here I generated output file, hex file, and that output file I loaded in the controller, which is possible. And when I run this, then here I can check the output. So the code which I have written is for AB, some input will come through UART communication protocol I have implemented. So data is coming through UART. Whatever I type here, that is simulated like coming on RX, the pin on the UART. And then when I type hash, before hash, whatever was typed, that will be displayed on the LCD. So this is UART communication implemented, some RFID or GSM. Through that, suppose if I am getting some data, that data I received and that data I display on the LCD. So here all the devices are available. Basically, the point speaking is controller is available, LCD is available, virtual terminal is available, oscilloscope is available, power, ground, multimeter, clock sources are available, resistors are available, everything, means all hardware stuff is available. So here you can cross verify whether your code is working or not. Here also that's possible. Here also debugging, here LCD is not possible, but other pin level things you can check. UART thing here you can check. System debugging is possible. Internal of the systems you can check. You can debug, you can do step run. So this is how we step run actually. This is how we step run. So lots of possibilities are there. And these are obviously these all things will be needed in the industry. And what we try is we try to get it as close as possible to the industry, what is actually happening in the industry, what they actually demand. So our motto is not to place the people. Our motto is to make them skilled. Our motto is to impart skills and develop logical levels and make them understand how to read technical documents, how to write a code, then how to figure out multiple possibilities, basically being a programmer. So that's what the main motto behind this course. So industry level application point of view discussions happen here. And plus in online batches also we have succeeded in giving the similar kind of effect which we do in the offline. So what happened after COVID, during the COVID period, we did not have option. Everything was closed. That's the point when we started online batches. Before that, we had only offline batches. But surprisingly, we got good response. And plus, we were actually majorly interested in whether are we able to deliver or not. That was the main question mark for us. Whether people are taking admission or not, that's not the main thing. Because if they take admission, whether we are able to give them whatever they came for, that's the main question. And surprisingly, during COVID and after COVID also, we got to know yes, we are able to create similar kind of effect in online sessions also, in microcontrollers, programming languages, everything. And those who can come to our center once in a while, like once in a month or like that, they can come and use hardware also. So means both way it goes. The discussions happen in very much depth, whether it is online or offline doesn't matter. And plus they are also allowed to come down to institute and actually use hardware and try hands on. But let me tell you one thing, sometimes people have a misconception like, but if it happens on online, online, uh, some practical part will be missing. No, that's the point, practical part will not be missing. So here we are targeting firmware developers profile, and that is basically about logic building and programming. So right, to be able to write this code which is working and efficient is the main point. To try whether it is working or not in simulation software also you can try it. Then the only thing which will be left is what? Only thing left will be whether this code will work on actual hardware or not. That's the only thing. So if I can write this code, I can generate output file, and my code is working here, that means it will work on actual hardware also. It is almost guarantee. The only part left will be how to connect actual hardware to PC and how to load the output file in the controller's program memory. That is a procedural part, not logical. Procedural part takes no time, है ना? Procedural part takes zero time. Main time consumption happens for what? Logical part. So logical part is a coding, programming. So that you can easily understand whether it is online or offline. So we spend time, we make sure that we are delivering similar quality. And we also found that in last few years, means from COVID, lots of people approached for online batches also. They got the job also through after online courses. So it made a similar kind of impact. And plus if you're physically nearby to the Pune location, then once in a while you can visit, you can hands on or on hardware also. And if needed to compensate for a speed or something, really real thing, face to face interaction ka effect, some sessions if needed, depending upon the demand of audience, we also dedicate some sessions for doubt discussions also. And one more last important point I will tell is here, we emphasize more on practical implementations. Means generally how the training goes is, first of all, suppose if some topic conducted, then on that topic, considering all the permutations and combinations of that topic, we give some assignments per topic. So it is like some assignment, some topic was discussed in details with some code examples and with industry scenarios. Means why this thing is used in the industry, how it is used, what are the permutations and combinations. So topic will be discussed in depth first of all, and after that we give some assignments. Assignments are deliberately designed in such a way that they take you closer to the industry, considering all the possibilities how they are actually used in the industry. So if the journey goes like understanding, implementation, understanding, implementation, understanding, implementation. During implementations, if you face problems, then you can talk to the trainer and gets your doubt sorted. In sessions they can be discussed if majority of people have it, or we create groups, and on groups also technical discussions happen if somebody has any doubt. So it goes like understanding and implementation parallelly. And a result of that would be after some span of time you end up developing good level of skills, and then we start providing placement assistance also. Then you go for placements and lots of companies are available. That's how it goes. Anyone has any question to ask? Any technical queries or anything in your mind? If you have course details, browsers and durations and dates, those details you will get from the Vaishnavi ma'am. She will share with you all the details if in case if you want. But the any technical things, I'm on the training side actually. So if you have any technical queries or about the course or future scope or something, then you can please ask. Anyone?
No, sir.
Hello, sir.
Yes.
Sir, what is the duration of this online course?
Actually, what happens? The duration of the offline course is 6 months, but online it is bit extended because we go with a moderate pace. Because we understand if we go with the fast pace, then it might create bit issues for understanding. So speed we bit drop down in online so that the understanding level will be maintained. So it goes up to around 7 months, sometimes eight online. But right now, what we are doing right now means it has happened after COVID. We started this. What's happening? Majority of the times, it has happened that some batch was going on online or offline, both actually. And some companies came for recruitment, and companies said ki we are okay if people have done C programming and one microcontroller, sometimes two microcontrollers. So companies are like desperate. Companies do not want to wait for people to complete their course. So sometimes course is halfway, some companies come, we tell them the course is not completed. And if companies are still okay, and nowadays they are okay actually because lots of demand is there. So in last many batches, majority of the people, at least means whatever people did the course, out of those 90% people got placed before the completion of course. But that's not the way we used to do previously. We are doing this because companies accept this. If companies say no, we cannot take researchers before course completion, then we cannot give. But companies are saying okay because there is a huge demand in the market. So for last many months after COVID actually, the demand is very high, and majority of the people are getting placed even before completion of course in few months. Means one C programming and one, sometimes two microcontrollers, they get placed. And then the question is ki after suppose in the middle of a course or 70% course is completed, and if you get placed, then what about the remaining things? Then that's what the online batches timing we have decided accordingly. So online batches we are conducting in the evening 8:30. So that means people who got placed, or some people who are already working, they also can attend this. So they can keep attending the course even after getting placed. So that's how it goes. So in the tomorrow's session, so now last and today's session was a bit of idea about the field and what is the mindset actually, what are the expectations of industry. In tomorrow's session, I will completely talk about one technical topic. I will pick one technical topic, either C programming or some controller. Any one topic I will pick, and I will explain one topic. So you will get an idea ki in online sessions how technical discussions happen and what is the level of depth we discuss here in this course. So you will get an idea what is the level of details we discuss here, and whether you understand or not. So you yourself will get the feel, touch and feel of the session. Okay, so tomorrow's session will be completely dedicated for the technical topic. And if you have any, yeah, yes, Saurabh,
Yeah.
any question?
Yes, sir. Actually, what are the minimum required to get easy going with this course? Means what kind of knowledge we have to must know?
Nothing, zero.
Okay. Means you are studying, means teaching from scratch.
Yes. Only expectations from our side is willingness and dedication, because this is not any skill. Means same thing happens for any skill actually. What happens, ki if I understood something, and that day itself if I implement it, then it becomes concrete. If I keep procrastinating and delaying things, then there are chances that you lose grip on that topic and you are actually not adding skill. You just listen. So this is actually implementation oriented course, and we planned it accordingly. We have planned assignments, and it has to be implemented time to time. Some projects will be given, some small projects will be given for implementing on microcontrollers. So if it is taken hand in hand, then guaranteedly you develop skills at the end. And we basically intend to work on thought process rather than grammar level discussions. College level discussions will not happen. It will be in very much depth. And even if we say ki we expect this particular skill, or if you know programming already, then you will learn fast. But unfortunately, the level of skill expected in the industry, that kind of discussions happen almost nowhere. In India, there are very few colleges, few institutions where the depth discussions, industry oriented discussions happen. Otherwise, majority of the universities and colleges, like exam point of view discussions happen, definitions, bookish definitions, and marks, exam oriented studies happen. So that is not needed, that is not expected, that is not even useful. So even if means even if you say ki, I know C programming, after few days you understand ki what actually what level is actually expected in the industry. Definition level, those things, controllers, even if you say I know controller. So here the next level discussions happen. And I already told other people from other background also do this course, mechanical background, say they don't know electronics, they don't know software, so they also learn it. So basically anybody can learn it, but that person need to have a consistency and dedication. Actually means how you decided, how determined you are. So skill addition is a big thing actually. It's not just attending something, it's sticking to it for some span of time. You decided, okay, few months I will stick to it, I will practice it on a daily basis, and I want to develop skills. So that's your goal, and you are very much determined for it, and whatever support you need for that, that is obviously available from our side. So it's a two-way commitment. We commit to give quality, you commit to practice. That's how it goes, simple. And that's how it any learning process goes. If anyone says you just join the course and we will make you something, that's not possible. Without your involvement you cannot become anything. That's not possible. If anybody is committing, you just join and you will get a job, then most probably that's not a quality discussions happening. Because if you are not getting involved, then how will you improve as a person, as well as thought process and logical capabilities? That's impossible. So joining does not assure getting a job. Even getting a job also does not assure a career. Making a good career means becoming a better person. Simple, straightforward relation. If you are logically improving, technically improving, then you can easily survive and grow. You can easily get a job. So getting a job is not a question at all.
Okay, sir. Yeah, I got it. One more question, sir.
Yeah.
Actually, while implementing some projects, the hardware will be provided from your side, or we need to manage?
Implementation of project means, first of all, you understand, implementation of project means what? Generally, college level expectations are you do means call engineering colleges or MEM Tech, any colleges, they expect literally to do invention. Project means they say you come with some very high fund, a new idea which was never done. So basically, they are asking you to invent. Project doesn't mean it. Project means integration approach. Means, for example, in microcontroller, I learned timer, I learned UART, I learned external interrupts, I learned analog to digital converter, I learned LCD. Now, if I give you some problem statement which combines it, which combines everything, and plus your code gives guarantee that everything will work, loss of event will not happen. Means it should not happen ki my controller was displaying something on LCD and that's why keypad was not working for some span. This must not happen. That is the project. So first of all, on college level, what they call project, that project ka definition itself is wrong. Project means they say ki high funda idea, who implemented, where you got the code from, where you whether you understood what means, what do I need to understand from project? That is not even question. So project does not mean some unique idea. Project means something which is slightly challenging for you, slightly challenging for you, which you yourself implement, and from that you understand how to integrate number of functionalities, plus making sure that any loss of event is not happening. Ki you are through your some data came and that was lost because I was busy in some other functionality. My controller can do one functionality at a time now, either keypad or LCD or like your laptop. If you are typing on keyboard, so and from browser you are downloading some data, so can it go parallelly? So can you make sure that I am downloading some data from internet also, I am typing something on the keyboard also, I am playing some music also in the background, and everything is happening with a single processor in the laptop. Same is the expectation in embedded system also. I have LCD also, keypad also, timer also, UART also, lots of things, single controller. So how can a single controller take care of all the functionalities? That's the question. This is what we need to understand from a project. Okay, so that can be implemented here also. So you don't even have to purchase the hardware for making a project. In simulation, you can make it, or at institute boards are available. So if you say, I am ready with the code, because code for implementing code, you don't need hardware. For implementing code, you don't need hardware. You need hardware for cross verification. That is available at the institute. So major area hardware, costly purchases, you do not have to do.
Okay, sir.
Yeah. Okay, so that was all for today from my side. Still, if anyone has any questions, you can please, or I will always be available. If you want to talk to me at any time, unless and until I'm not in session. So if I'm in session, I'll not be able to talk on the call. But otherwise, I'm available at the office. You all of you have the office mobile number. If you wish to have any technical discussion, if you have any technical queries in daytime, also you can call me on the office mobile number. I will be available there, or I will call you back as soon as I get free. Tomorrow we will continue. Tomorrow we will have a purely technical discussion. Tomorrow also you can come up with any questions if you have. Okay, so that was all for today.
Okay, sir. Thank you.
Yes, thank you.